Hey, this is Craig Allen, your Microsoft dude. I'm here to talk to you on one of my 5-minute tech talks about some exciting new technology in our 14th generation Dell EMC PowerEdge servers. This works with SQL Server 2016 or 17. This is to get the maximum performance out of your transaction log, something called persistent log buffer. Let's get to it. If you don't know who I am, my name is Craig Allen. I've been with Dell EMC for 7 years. I was at Microsoft before that, and I was in corporate IT for a long time. So feel free to send me a tweet, hit my blog, or send me a LinkedIn request. So persistent log buffer. This is taking the transaction logs of SQL Server and putting them up in the system server RAM. If you don't watch the rest of this video, at least you'll get one thing out of this. This is extreme performance. This does require the PowerEdge Server 14 generation non-volatile DIMMs. So let's talk about NVDIMMs and what is it? Well, NVDIMMs is a non-volatile memory module. And the dash N after it means it's byte addressable. So this is a standard memory module. It's got standard DRAM on it. So this is not running at your milliseconds or your microseconds. This is running at nanosecond speed. But this is persistent in the fact that there is flash also on this module, and there's a controller on the module. And this thing also has a battery backup to it. So let's explain how it works. In the event of a server shutdown or power loss, what the controller does on the DIMM memory module is copy all the DRAM information to the flash area for persistent storage. This is done with power that's supplied from a battery. Now, the inverse, when the server comes back up, the controller will copy all the flash information back down to the DRAM chips. So this is a picture of the NVDIMM. And there's some LEDs on it to give some status information. Over on top right, there's a connector for the battery pack. This is all configured through the BIOS of the server. So one thing you can do with the databases is you can take your tables and you can pin them up in the server RAM. And that's called a memory optimized table. These are durable tables, so they're protected. The problem with this is you're getting great speed out of the tables, but your transaction logs, which is a list of all the transactions hitting the database, are still disk bound. So our databases may be running at nanosecond speed, but our transaction logs are still running at millisecond speed. First of all, let's talk about the transaction logs. Every single transaction that hits the database is recorded. So the transaction log is a record of every single transaction in order. The transactions actually hit a part of memory called the transaction log buffer before they actually get written to the transaction log. So the transaction log files actually live down on block storage, on persistent storage. And the main use of the transaction log itself is to protect the database. So if we have a crash, we can restore last night's backup, and we can roll our logs forward to the most current point in time. Since the transaction logs live on block storage, we're limited to that speed. So the speed of the transaction logs kind of govern the total transactions per second we can get. So let's take a look at how it normally works. So we have our transaction log buffer up in memory. And once we get enough of these transactions in the buffer, we'll get something called a transaction log block. And that block is actually then written down to the transaction log file. And once it's actually written to the file on persistent storage, then the transactions are considered committed. So you do have transactions still sitting up in the log buffer that haven't been committed to the file yet through a block, and those are called the tail of the log. So those transactions are at risk. If you lost power, you would lose those transactions, so those transactions are not committed. So let's see how this changes the game with something called persistent log buffer. We still have the transactions hitting the location in memory, the buffer, but what we're doing is that location is sitting on an NVDIMM and it's persistent. There's a battery backup and there's flash. So what we've done is we've formatted that with something called the DAX file system, and we'll talk about that here in a second. But now, rather than waiting for a block of transactions to get written down to the transaction files, we are committing every single transaction as soon as it hits the buffer. And so there's no more waiting to collate a whole bunch of them together to write down to block storage. Now there is still a finite amount of space in the buffer, so we've got to destage. We've got to make room for the new transactions. So there's an asynchronous flush process that still takes the transaction log blocks and writes them down to the transaction log file. But those transactions have previously been committed. So we're still receiving transactions into the buffer, and those are instantly being committed back to the application. Now, this new file system called the DAX file system, we all know about NTFS and its bigger brother called REFS. So those block file systems can still be used against an NVDIMM in the server. You know, it would show up as a drive letter, but you would only get so much performance. If you used NTFS, traditional NTFS to format these NVDIMMs, it'd be like a very, very fast solid state drive. The DAX file system is very skinny. They've taken out a bunch of layers, got everything out of the way, and now the CPU can memory access or byte level access the NVDIMM modules. So if you format it as a block device, it would be block access. If you format it with the DAX file system, you would be byte level address those memory ranges. Now, what kind of performance are we actually talking about here when we do this? Well, you know, since we're running at memory speed, and since we are byte level accessing those memory modules, we're running in the millions of IOPS, and we're running at nanosecond speed or sub microsecond speed. So now, like I said, there's only so much room on these NVDIMM memory modules, so you've got to pair it up with a really fast standard storage device so we can do that D-stage process. So down here at the bottom, we can compare, put in our transaction logs just on NVMe standard flash drives in the server, and we get really good performance. In this example, 1.2 million. But when we pair that up with some storage class memory or this persistent log buffer that's receiving the transactions first and then immediately committing them, you can see that we're getting 2 to 3x of performance. Persistent log buffer, transaction logs running at core memory speed, extreme performance. It's a great way to use the benefits of the 14th generation servers from Dell EMC and NVDIMM technology. So hit me up, let me know what you think. I think it's pretty exciting, so I'll talk to you later.